All right, yeah, so here we have a really neat modified Z Schlieren system. So if you take a look over here, we have a high intensity LED light, and we built a plate for it. So we essentially embedded a variable iris from Thor Labs in here, so we can control the size of the point coming out of this high intensity LED. This hits on an Edmund Optics parabolic mirror. We have a collimation going across here where we do all of our shots. So we're looking at shockwave propagation coming out of different silencers and different weapons. The collimated beam hits the mirror here, and we have a nice sharp point here. If you could take a look, this is where we get a focused point, and then we have projected onto our high-speed Phantom TMX camera, where we'll be able to review the data. So if you take a look at here, here's a very interesting one where we are looking at a 12 gauge with a muzzle brake. So if I play this very carefully, you can see very interesting behavior of the round as it goes out here. And then we can immediately take this into our measurements platform, get shockwave speeds. The engineers developing these technologies for these muzzles can make informed decisions about how to design future tech. Now, in a typical Z Schlieren system, you want to generally have a knife edge right here, but in this case, since we have so much refractive index gradient, we actually just left the knife edge out. So we kind of have almost like a shadow graph system here instead of a quote-unquote classic Schlieren system. All right, so come get a close look at this. Here we have essentially a light block for our high-intensity LED. These are GS Vitek LEDs, and the engineering folks at Silencer Co. Built this custom rig where we can drop our variable aperture inside here, so we have really nice control over the size of our point source here. So as your point source gets smaller, you get less light, but you're going to get more sensitivity in your Schlieren. So we're essentially using one LED from this high intensity GS Vitek light. And these are great because they're extremely bright, and we can also strobe them down to hundreds of nanoseconds for really nice temporal resolution.